This video is on Unit 2, Chapter 6, Quadratics Extras, Lesson number 1, Quadratics Application. In this lesson, we are going to be focusing on word problems centered around quadratics. So we're going to use what we learned in Chapter 5 to solve a quadratic once we get these equations set up to solve and answer each of these questions. So let's look at question number 1. Number 1 says the width of a rectangle is 6 meters less than its length. If the area of the rectangle is 112 square meters, find the dimensions of the rectangle. So we know what a rectangle looks like, and you should also know the area formula for a rectangle. Area of a rectangle is length times width. So in this word problem, what we have to do is we have to set up our variable, and it's either going to be L or W, and you've got to figure out which one it is. It gives you the area, and then in the first sentence it says the width of a rectangle is 6 meters less than its length. So ask yourself, which one's my X? Well, your X is going to be the length because it tells us the width based on that. The width is 6 less than X. 6 less than X. So X minus 6. The words less than, if you think back to the word problems that we did early on in the semester, when you see the than following the word less, that means reverse the order. So instead of saying 6 minus X, you have to say X minus 6. All right, so let's plug in our stuff. What is A? That's the area. And in the word problem, it says the area is 112. So we're going to substitute in the 112. The length is X, and the width is X minus 6. So what we have to do here to solve this is use our distributive property to multiply. X times X is X squared, and X times negative 6 is negative 6X. So what just happened in that step is we've just created a quadratic, and what makes it a quadratic is the X squared. So to solve a quadratic, this one has a 6X, it has a BX. We're going to solve by graphing. We're going to hope that we can solve by graphing, which means we need a 0 on one side. So I'm going to subtract the 112. And then I'm going to solve this by graphing. So I'm going to go to the y equal, and I'm going to put in the x squared minus 6x minus 112, and I'm going to hit graph. Now, when we look at the graph of this, I only see one solution. I'm going to hit zoom out, which is 3, and then enter. So you can see your two solutions here. Now, the left side looks like it's about, what, a negative 7 maybe? 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. Maybe a 14 on the right. Let's go to the table of ordered pairs to make sure we can see. So 14, I did count correctly. I counted 14. 14 is one of my solutions because the y value is 0. So I'm going to write down 14. And then I'm going to arrow up to see if I can find, I thought it was what, negative 8. Negative 8 is my other solution because, again, the y value is 0, so negative 8 is my other solution. So with word problems, I'm going to need you to use a little bit of common sense here. If the length is x, can x be a negative 8? Can x be negative 8? Because that's the length. No, it cannot. The dimensions of a rectangle cannot be negative. So the negative 8 is not going to work. Only the 14 is going to work. So the length of my rectangle is 14. Use the correct units. It's going to be meters. The width, take your 14 minus 6, and the width is 8 meters. So there's the answer to number 1. All right, let's look at number 2. Number 2 says the length of a rectangle is 1 foot more than twice its width. If the area of the rectangle is 300 square feet, find the dimensions of the rectangle. So this one is almost identical to question number 1. Again, we're going to be using the area equals length times width, and ask yourself which one's the X, the L, or the W. The length of a rectangle is 1 foot more than twice its width. So the width in this one is our X, and the length is 1 foot more than twice that. So 1 plus 2x. Now, if you wrote 2x plus 1, that's the same thing. It doesn't matter the order there. Now, let's plug everything in. Area is 300. The length is 1 plus 2x, and then the width is x. So again, using our distributive property, actually, that's supposed to be an x. Using our distributive property, we have 300 equals 1 times x is x. 2x times x is a 2x squared. I'm going to subtract the 300. We need our 0 because we've got a quadratic. Also, on the right side, this is not in standard. What needs to go first is the x squared, and it's a positive 2x squared, then the x, and then that minus 300. All right, so let's look at my graph. 2x squared, y equals 2x squared plus x minus 300, plus x minus 300. All right, so let's look at the graph. It's hard to see this. If I hit zoom 6, it's not going to help because you don't see anything. So being zoomed out is the only way to see what these solutions are. Here's a negative one over here and a positive one. I'm just going to disregard the negative one because I know I can't have a negative answer. So I'm going to look for the positive one. It looks like it's at 3, 6, 9, 11 maybe. Let's look at our table. FYI, I am going to look here. I can't see that answer. Interesting. But it's negative. It doesn't really matter what that one is. Looking for a 0. Found it. It's at the 12. So x equals 12. And again, I don't care about the negative side. I don't care about this negative answer because when we set up our problem, x represents the width of the rectangle, and it cannot be negative. So the width is 12 feet, and the length is 1 plus 2 times 12. 1 plus 2 times 12. So that's 25. So there's number 2. Let's look at number 3. Number 3 says the dimensions of a rectangle can be expressed as x plus 6 and x minus 2. If the area of the rectangle is 65 square inches, find the dimensions of the rectangle. So number 3 is almost identical to number 1 and number 2. The difference is it's already set up for us. Our x plus 6 and our x minus 2 represent the length and the width. So we can go ahead and set up our problem. Area is 65. It doesn't matter which one you put in first. And then we're going to distribute to multiply our parentheses. X times x is x squared. X times negative 2 is negative 2x. 6 times x is 6x. And 6 times negative 2 is negative 12. We need our 0. We've got a quadratic, so I'm going to subtract the 65. It's like the 12. So subtract that. And we're going to combine our like terms. The negative 2x plus 6x is a positive 4x. And then negative 12 minus 65 is negative 77. So let's graph. X squared plus 4x minus 77. X squared plus 4x minus 77. Graph. Again, the negative answer is not going to work. We can try to find it in the table. And it looks like maybe 6 is our answer on the right. Oh, nope, I was wrong. It's 7. So the y is 0, where x is 7. If you were looking for the negative answer, it's negative 11. So negative 11 and 7 are the two solutions. But again, the negative 11 is not going to work. The 7. So my length and my width, actually it doesn't specify which one's the length and which one's the width. So we're just going to do dimensions we're going to write our dimensions a different way. What is 7 plus 6? 7 plus 6 is 13. So that's 13 inches. 5. What is 7 minus 2? And that's 5 inches. So the dimensions of that rectangle are 13 by 5. We are going to talk about number 4 later. We're going to completely skip number 5. And number 6 is talking about a rectangular prism. So we're going to skip that one as well. And I'm going to jump to the consecutive integers, number 9 and number 10. We can talk about 7 and 8 later as well. So number 9 and number 10 go back to those consecutive integer questions that we've dealt with in the past. Remember that the first one is always x. If you're talking about consecutive integers, the next one's going to be x plus 1 and x plus 2. If we're talking about consecutive even or consecutive odd, then we need our x plus 2 and x plus 4. So let's look at number 9. Find two consecutive positive odd integers such that the square of the smaller integer added to 3 times the larger integer is 24. So consecutive odd integers. Now, I'm not going to focus on the word positive yet. That word is there so that when you get a positive answer and a negative answer, you disregard the negative. I need 2. So I'm going to label that 1 and 2. And remember that the first one's always x. Now we are asked to find consecutive odd. So that means the next one is x plus 2. And then we're going to use the such that to set up our equation. So such that the square of the smaller, so the first ones are x, which is the smaller, x squared, added to 3 times the larger is 24. So that's setting up the equation. And then, of course, we're going to use our distributive property and get our 0 on one side in order to solve. So x squared plus 3x plus 6 equals 24. Subtract your 24 to get your 0. And then let's solve by graphing. X squared plus 3x minus 18. Let me hit zoom 6. So again, the negative solution, which looks like is a negative 6, I don't need it. I'm not looking for a negative integer. If it said negative, then the negative 6 is one I would need. Right now, I just need x is equal to 3. But the negative 6 doesn't work. So now it's asking me the two integers. Well, if x is equal to 3, one of them is a 3, and then what is 3 plus 2? Well, that's 5. So my two integers are 3 and 5. Number 10, last one, says find 3 consecutive positive integers such that the product of the median integer and the larger integer is 72. So I need 3. The first one's always x. Notice that it just says consecutive integers. So that lets me know that the next ones are x plus 1 and x plus 2. Again, the word positive is there to let us know that we're only going to be focusing on the positive solutions. Find the words such that, and then let's set up our equation. Such that the product, which means to multiply, the median, and the largest is 72. So let's distribute X times x is x squared. X times 2 is 2x. 1 times x is 1x. 1 times 2 is 2 equals 72. And then from there, I need to get my 0 and combine my like terms on the left. So I have x squared, 2x plus x is 3x, and then 2 minus 72 is negative 70. All right, let's solve by graphing. X squared plus 3x minus 70. So it looks like a negative 10 and a 7. And again, you can confirm that in your table. So negative 10 is one of my answers, and the 7. Negative 10 and 7. But again, just like on all of the others, the negative 10 is not an answer because it specifically said we just want the positives. So the first number is 7. 7 plus 1 is 8. And 7 plus 2 is 9. So my 3 integers are 7, 8, and 9. And there are your notes for Unit 2, Chapter 6, Lesson number 1.